Hey guys, this is Mr. Lowry. I wanted to kind of go through the proofs that you're going to be doing in your homework assignment or for your homework on this Triangle Congruence Proofs worksheet. So these are just taken out of the book. I just thought it might be helpful to print out a worksheet with the number on them for you so you didn't get confused. But you're going to use your book to write and complete these proofs. And this is the first one. This is number 17 right here on page 204. Okay. So I'm going to have you write the proof out yourself, but let me just give you some hints here. The given, it starts out with a triangle congruent statement right here, right? You just got to figure out which triangle they're talking about. So MRN is this guy, and then QRP is this guy. So don't do this. This is this is not something that I would normally want you to do, but I'm going to go ahead and shade these. I'm going to be really careful. I'm going to come back and erase this later. But all right, bad example, but I just want to kind of, give you an idea of what's going on. The congruent statement itself that's given in the very first one says that these two triangles are congruent, right? And your goal is to say that MNP and QPN are congruent. So we want to find out that these overlapping triangles are congruent, okay? So when you have the two dark ones congruent, what you can assume is that every side and every angle has a corresponding congruent side or angle, right? So this guy's congruent to this guy, this angle, this side's congruent to this side, and this side's congruent to this side, and this side's congruent to this side, right? You can just, you can make that, well, you can't assume that, but you can make that inference from that piece of information, right? So once you state this given information, you could say something like MN is congruent to QP. And the justification you're using is CPCTC, that abbreviation that we talked about earlier. CPCTC stands for corresponding parts of congruent triangles are congruent. So since these two dark shaded triangles are congruent, QP is congruent to MN because those are corresponding parts, right? MR is congruent to QR because those are corresponding parts. RN is congruent to RP because those are corresponding congruent parts. We have, angle M congruent to angle Q and all that kind of stuff. Okay. Now it also gives you this other angle, MNP, which is actually a little bit bigger than any of the it's bigger than the actual angle in the shaded triangle. It's one of the angles of the bigger triangle here. All right. So a couple things to notice. The bigger triangles here, right, they both include this side. They're sharing that side, okay? They also both have these in common, okay? So that's another thing you can do there. So there's more than enough information here to say that the two bigger triangles are congruent, but that hint I wanted to give you is to use that idea, CPCTC, we talked about in the example proofs for today. Okay. So there's a reflexive side that they have in common, right? That's kind of one idea. Use CPCTC, they give you another angle. That should pretty much get you there. Okay, let's jump to the next section here, and I can talk you through some of those. Okay, one of the other proofs you're going to be doing is this guy. Sorry, it's kind of hard to get all of these with the document cam, but this is the next one. Okay, so we talked about keywords, looking for keywords. QS bisects. Okay, bisects is a really important word. It means cut in half. Okay, and it cuts this angle in half, RST. Okay, so this segment cuts this angle in half, which means you're going to have congruent angles here. All right, so keep that in mind. They also give you this other angle, right? They've already got it marked, and you've got a reflexive side there. Okay, so with that, you have enough information to say the triangles are congruent. You just got to organize it and use your justifications. Okay, so the keyword bisects is going to give you some congruent angles, right? And you have a side that they're sharing, which means you're going to have to use the reflexive property of congruence. All right, on the other page here, let's see if we can tee these up a little bit. All right, so look at number 11. Now number 11 is actually not asking you to find congruent triangles. Okay, it's actually asking you to find two congruent sides, right? VR, this guy, and SR, this guy. Okay. Now how you're going to do that is you're going to start by proving the triangles are congruent. So if you can show that this triangle is congruent to this triangle, once you do that, then you can say, okay, now that the triangles are congruent, every other piece has a congruent piece, right? And the justification again is, CPCTC. Okay, so if you're not sure how to use CPCTC, go back and watch the example proofs that I did in a previous video, example proof 1 and example proof 2, where I used that a couple times. But again, one more time, the idea is once I prove these two triangles are congruent, then I can say, well, if these two triangles are congruent, then VR is congruent to SR by CPCTC. Corresponding parts of congruent triangles are congruent. Okay, let's look at 14, which is another one you have to do. Okay, again, another key term, midpoint, right? Midpoint, what does that tell us? Z is the midpoint of CT. Okay, that's giving you congruent sides. So again, don't do this in your book. I'm setting a bad example here. Okay, but those two guys are going to be congruent because that's what midpoint means. Okay, also you have parallel lines, right? So parallel lines with a transversal is going to give you alternate interior angles. So keep that in mind. You also have all kinds of vertical angles in here, right? So you got some vertical angles here, you got some vertical angles here. Okay. Now, again, the proof here, the goal is not to prove that two triangles are congruent, although that is going to be part of the proof. Your final goal is to say that YZ, this guy, is congruent to EZ, this guy. All right, so if you can show that you have a pair of congruent triangles, either these two or these two, right, then you can use CPCTC and say, okay, well, if I have two congruent triangles, then this part of one has to be congruent to this part of the other. Okay, so parallel lines are going to give you alternate interior angles, so keep that in mind. Just keep in mind which ones are parallel, right? These ones aren't parallel necessarily. It's these guys. Okay, so make sure you grab the right angle in there. Okay, you got vertical angles in there that you can use, and you have this midpoint idea. All right, so that should help you kind of get through that one. All right, and the last one here, okay, number 16. Whoops. Okay, again, we have this keyword bisects, right? DL bisects BN. Okay, that means DL cuts BN in half. Right, so we got congruent sides there. Okay, you got vertical angles in here as well. So you got vertical angles here, you got vertical angles here. Right, now, one more time, this is not asking you to prove two triangles are congruent. That's not the final piece to the puzzle. However, that is the triangle congruence is what you're going to do along the way. Okay, so what I would do is I would show that this triangle on the bottom is congruent to this triangle on the top, okay? And if you do that, then you know that this side is congruent to this side, again, by CPCTC, okay? So in order to get two sides congruent, start by showing the triangles are congruent, using other sides and other angles, and then you'll get every side and every angle, basically. Okay, so that's not going to, walk you through the whole thing, but that's kind of the hints here. If I do too much more for you, then it kind of defeats the purpose of you thinking through them. Right? Proofs you're kind of trying to use your own deductive reasoning here. So I've given you a lot of hints that you're going to use, and you can kind of set the proof up and structure it, make sure you justify your reasoning. But those are some hints. One more time, if you go back and check out the example proofs, they're not exactly the same. You can't follow them line for line, but they have some examples on how to use that idea of CPCTC. Corresponding parts of congruent triangles are congruent. So if you haven't already, or if you need to again, you can go back and check those out. And then I hope that helps you. Thanks.